Today is day 6 of Unit 9. We started today with this warm-up, so take a moment and work on the warm-up, pause the video, and then play to check your answers. So probability of rolling an even number given rolling a number less than 4. You can either use logic or the formula. I'll use the formula first. So rolling a number less than 4, that's the given, so that would be 3/6. And the numerator is both events, so even and less than 4. So if I'm thinking how many numbers on a die are both even and less than 4, there's only one number that's even and less than 4, and that's the number 2. So that's 1/6 out of 3/6. So then 1/6 times 6/3 simplifies to 1/3. Other way would be using logic. So start with the given. The given is rolling a number less than 4. So that would be 1, 2, and 3. 1, 2, or 3. Of those numbers, 1, 2, or 3, so by the way, my denominator would be 3. Of those, there's only one that is both even and less than 4. So that would be one number out of those 3, which is 1/3. Either way is fine as long as you show your work explaining how you got 1/3. Okay, so today we started working on the first problem on page 19 together. So we'll do that now here. And I did mention in class that some of the problems on pages 17 and 18 were a little bit tricky because I had not shown you how to do that particular type of area diagram yet, and that's what we're going to go over here now. So even though 17 and 18 were previously assigned in the homework, I would like you, after we go through these problems today on pages 19 and 20, I'd like you to go back and redo or fix any of the ones that you didn't know how to do on pages 17 and 18. So first of all, the problem on page 19 says, on the midway at the county fair, there are many popular games to play. One of them is flip to spin or roll. You start by flipping a coin. So, and we're supposed to make an area diagram. So go ahead and make your area diagram, and if I'm starting with the coin, then I have to do that first. I have to take care of that on the diagram first. Now, it doesn't really matter if I split it up the top or alongside, but I have to start with the coin because that's how this problem starts. So I'm going to put the coin along the side, and it says if heads or tails comes up, different things happen. Well, so that means obviously that my probability of heads is 1/2, and tails is also 1/2. So then it's saying that there are 10 equal sectors. If we get heads, there's a big wheel which has 10 equal sectors, and if we get tails, there's a cube with 6 sides. So don't know what happened there. So what happens here is this one's a little bit different. I don't know why that's cutting out. Hopefully that doesn't do that again. But so we are going to set this diagram up just a little bit differently, because if we get heads, we go to the wheel. If we get tails, we go to the cube. So what happens here is there's actually 2 more events after that first event. So there's 3 total events. So what happens is the wheel goes up top because that's off of heads, and the cube goes down there because that's off of tails. So then when we divide up our sections for the wheel and sections for the cube, we'll only go up to the halfway mark. We won't go all the way through like we have in the past. So with the wheel, there's 10 sectors, 3 red, 3 blue, and 4 yellow. So hopefully you can get the probabilities there. That would be 3/10, 3/10, 4/10, which is 2/5. So I'm going to go ahead and divide up, trying to make 3 sections, one that's just a little bit bigger than the other 2, and that bigger one is the 2/5, which is yellow, and then the 2 that are the same are red and blue, and those are 3/10. So then I'm going to multiply each one of those by the 1/2 here to get these 3 internal probabilities. So 3/20, 3/20, and 2/5 times 1/2 is what? 1/5. So I'm going to now divide up the cube sections. So we have, it says 3 red, 1 blue, and 2 yellow. So 3 out of 6 is half. So I'm going to split that up in half. That would be the red. And then I have 1/6 and 2/6, which is 1/3. So I'm going to try and make the 1/3 twice as big as the 1/6. So this is the probability of yellow is 1/3. And the probability of, all right, it needs to stop doing that. The probability of blue is 1/6. Okay, so multiplying those by this half, and all right, hopefully it doesn't do that again. So keep in mind these numbers don't necessarily always have to be the same. They're not always going to be half and half, but whatever the number is here times these three probabilities. So 1/4 and 1/6 and 1/12. Okay, so now we have our diagram, and then there are several questions on page 19 that go along with that diagram. So we'll just run through those now. So what's the probability of winning a stuffed animal? Well, it says in the problem, if your spin lands on blue or the blue side of the cube comes up, you win a stuffed animal. So blue is here or here. So I'm going to, this is for part B, I'm going to add those because we know with or means add. So I'm going to add 3/20 to 1/12. And of course, I'm going to need to get a common denominator there. So our common denominator is 60ths. So 3/20 in 60ths is 9/60ths. And let's see, 12 would be 5/60ths. So when I add those, I'm getting 14/60ths, which simplifies to 7/30ths. So that is my answer for part B, which is the probability of winning a stuffed animal. So then next, C says, Tyler won a stuffed animal. What is the probability he started off with heads? So, well, in other words, they're asking us, what's the probability of heads given stuffed animal, which means blue? So we know using our conditional formula, blue is the given. So the given goes in the denominator. So that would be the 3/20 plus the 1/12, which we already did a moment ago and got 7/30. So 7/30 goes there. Heads and blue is going to be my numerator. So remember, we get that from the diagram. We go to heads, we go to blue. Heads and blue is 3/20. So 3/20 is the numerator. So then multiplying 3/20 times 30 over 7 simplifies on the diagonal. So that's 2 and 3. That gives me 9 over 14. Okay, next part D, about how many times would you expect to have to play this game in order to win a stuffed animal? Well, we're going to go back to the probability of winning a stuffed animal, which is 7/30. But that means 7 times out of 30 times I play, I'm going to win. So all we have to do there is divide 30 by 7 and realize that around 4 to 5 times we would have to play in order to win. Okay, part E, if it costs $1 to play the game and the stuffed animal could be purchased at Bob's Bargain Basement for $3.50, was it worth it? Explain. Well, we just said we'd have to play 4 to 5 times, and if we pay $1 each time, then that's $4 to $5 that we are paying. And if it's only worth $3.50, then at least numerically speaking, monetarily, it's not going to be worth it, because even if we look at the smaller end, the $4 end, $4 is larger than $3.50. So it's not mathematically worth it. Now, you could argue that they had fun playing the game and so it was worthwhile, but just mathematically speaking, it's not. Okay, so that takes care of page 19, and then I just gave class time for students to work on page 20, which is similar. You're going to set up your diagram similarly. And then I just explained that, keep in mind, now we've done 2 different types of area diagrams. We've done this type where you start off on the side here, or even if you did that up top, that's fine. But you have to do that first event, and then based on the results of that event, or the outcomes, then different outcomes happen. So that's when we need to do both the top and the bottom, or if you started it on the top, the side and the other side. The other type of problem that we've done is just when you have two events. So when we pick from jar 1 and jar 2, we put jar 1 on the top and jar 2 on the side. That one, there's only those two events, and they don't have to go in any particular order. There's just those two events. So when you're starting a problem, decide, is it this type of area diagram, or is it the other type that we did the first several days with. So I want you now to work on page 20. We did not do that together in class. I just kind of quickly went over the answers at the end, so you can check those with me or another student. But do page 20, and then I do want you to go back and redo the problems on pages 17 and 18, at least the ones that you skipped or tried but did incorrectly. So go back now that we know how to do the diagram correctly and fix those on pages 17 and 18. So your homework for tonight is worksheet number 4. Now that is a correction from the calendar. It says worksheet 6, but it's actually worksheet 4. And then again, go back and finish up pages 17 and 18, fixing up any problems that you skipped the first time. Okay, do those for tomorrow.